Dear students, very good morning. Today we are going to discuss a new topic, that is Jacobian of implicit functions. That is Jacobian of implicit functions. Okay, that is Jacobian of implicit functions. Okay, Jacobian of implicit functions and Jacobian of partial derivatives. Okay, Jacobian of partial derivatives or partial derivatives, or we can tell it as partial derivatives using Jacobian. Partial derivatives using Jacobian. Partial derivatives using Jacobian. So these are the topics today we are going to discuss. These are the topics today we are going to discuss. Okay, and under these topics we are having some formulas. So we have to be thorough with those formulas. Jacobian of implicit functions and partial derivatives using Jacobian. First we shall split up the topic into two. One is Jacobian of implicit functions, and second topic is partial derivatives using Jacobian. So what is mean by implicit function? We know that, okay, when there exists a relationship between x and y and u and v, okay, and it is not possible to split those functions. And we are expressing those functions as, if suppose f of x comma y equal to c is implicit relation, means then we know how to find its partial derivative or total derivative. So the implicit functions mean the function which is a function of some variable, and those variables are also the functions of some other variables. Okay, some functions which are the functions of some variables, and those some variables are also the functions of some other variables. Okay, if both u okay, if I am telling like this, if u is the function of x and if x is the function of t, then we can call there exists implicit relationship between u and t. Okay, that is there exists implicit relationship between u, x and t. Okay, I hope you understand. Now we move on to the definition. If the definition is, if first if f1 of u comma v comma w comma x comma y comma z equal to 0, not only this is 0, also we are having two more terms, that is two more functions. One is f2 and f3. okay, one is f2 and another one is f3. okay, if f1 of u w x y z equal to 0 and other functions are f2 and f3, so and those three are equal to 0, means then we will have, okay, here it is f2 and here it is f3. If f1 of u v w x y z equal to 0, f2 of u v w x y z equal to 0, and f3 of u v w x y z equal to 0, or three implicit functions, we can consider u, v, w as implicit functions. Okay, f1, you have to understand very clearly, if these three are equal to 0 or three implicit functions, we can consider u, v, w as implicit functions x, y, z. Okay, u, v, w as implicit functions of x, y, z. Okay, you can consider u, w as implicit functions of x, y, z. Okay, implicit functions of okay, implicit functions of x, y, z. Okay, then implicit functions of x, y, z. Then we are having a formula, dou of u, v, w, dou of u, v, w divided by dou of x, y, z, dou of u, v, w, then x, y, z equal to minus 1 power 3 minus 1 cube of in the numerator we are having dou of f1, f2, f3. f1, f2, f3. In the denominator we are having, okay, in the denominator we are having dou of x, y, z, x, y, z whole divided by the same dou of f1, f2, f3 whole divided by dou of u, v, w, u, v, w. Okay, dou of u, v, w. Okay, now this is our formula for Jacobian of implicit functions. Okay, now for Jacobian of partial derivatives. We are having some different formulas. We are going to find partial derivatives using Jacobians. Okay, first here, if f1 of u, v, comma x comma y, u comma v comma x comma y equal to 0 and f2 of u comma v comma x, u comma v comma x comma y. Okay, two functions with implicit functions of u comma v of x comma y equal to 0, you have to write, or two implicit functions. These two are implicit functions, and if u comma v and if u comma v are considered as, and if u comma v are considered as functions of x comma y. Okay, u comma v are functions of, and if u comma v are functions of x comma y. Okay, functions of x comma y, then u comma v are the functions of x comma y. Then we are having a formula dou u by dou x equal to dou u by dou x. So we can find the partial derivatives using Jacobians. Okay, so dou u by dou x equal to minus, okay, so I'll write minus in the common, minus dou of f1 comma f2. Okay, f1 comma f2 divided by dou of x comma y, dou of x comma y divided by dou of f1 comma f2 divided by, see there is a mistake in the formula. Okay, so when we are considering x, we have to, it is v, not y, it is v. Okay, when there are two functions u and v, and if I am differentiating u with respect to x, means here we will get only v, and here we will get only u comma v. So dou of u comma v, okay, dou of u comma v. In the same way, I am going to write the second formula, dou u by dou y, and then dou v by dou x, and after that dou v by dou y. Okay, there are four formulas. Okay, the next formula. So I shall copy this formula. Control plus C, and I shall paste the formula here. So here, if I want to differentiate u with respect to y, okay, so what will happen? All the x terms will become y, so denominator is common, always common. So on few terms, and this v will be changed, okay. Here when I differentiate u with respect to y. Okay, so we know that both u and v are functions of x comma y. When I differentiate u with respect to y, okay, u, so that is u with respect to y means I will get what will I get? I will get y. Okay, I will get with respect to x means I will get x, with respect to y means I will get y. Okay, dou y, and then when I differentiate this u with respect to y means then definitely I will get v. So then definitely I will get v. Okay, definitely I will get v. You have to understand that. Okay, so when u is differentiated with respect to x, the first term is x and next term is other than u. When u is differentiated with respect to y, the first term is y and second term is other than u, that is v. So now we can copy these two terms together to understand our next formula. Okay, we shall copy these two formulas together and so that we can understand our next formula. Okay, now I am copying these two. I am copying these two and I am pasting it here. So now what will we have? So now we are going to find dou v by dou x and dou v by dou y. So when we are differentiating this dou v, okay, when we are differentiating this dou v with respect to x and dou v with respect to y, okay, dou v with respect to x and dou v with respect to y, then see, with respect to x means the first term is x, but the next term will be u. Okay, the next term will be u here. I am differentiating v with respect to x means here I will get u. Okay, here I will get here I am differentiating v. So for v means, so we have to understand one thing. First, with respect to u means we are writing x comma u. With respect to y means we are writing y comma v. But for writing v, okay, we have to change. We have to make little change. So instead of using f of, okay, here instead of using x comma u, we have to use u comma x. That is in the formula. Okay, that is in the formula itself we are having that changes. That is in the formula itself we are having that change. Okay, so first I shall write it like this for our easy understanding, then we can change the formula. Okay, so dou v by dou x equal to dou f1 comma dou f2 divided by dou x comma u is changed to dou u comma x. By means we are writing the partial derivatives with respect to Jacobian. So in Jacobian means it is a determinant. In determinant, the left half will have some value. So how we will get the product of main diagonal elements minus other diagonal element. Okay, that is how we are getting any determinant value. Okay, so when we are using such determinant, such Jacobian, to get any partial derivatives like this, the first half will be u comma x, means the next half will be x comma u. If first half is u comma v means next half will be y comma v means next half will be v comma y. Y comma v means next half is v comma y. So here it is. Now I am going to write here it is u comma x. Small change, u comma x, because we have to be very careful with the formula. So denominator is common for everything, and here f1 comma f2 with respect to I'm differentiating v with respect to y, and differentiating v with respect to y means, see, oh, here there is a small mistake in the above formula. So I'm differentiating, okay, there is no mistake here, do you, okay, now there is nothing mistake. Now we have to change it. V with respect to u means here it will be u, here it will be u, that is what usually we do, but here we have to change it, that is here it will become u comma y, here it will become u comma y. Okay, so small change, y instead of y comma u we have to write it as u comma y. Okay, so a little understanding of the formula is very important. Okay, little understanding of the formula is very important. So here we are having, instead of writing y comma u, we are writing u comma y. Okay, so these are the four, okay, these are the four formulas that are very important. Okay, okay, just a minute. For your easy understanding, I shall display the formula fully. Okay, I'll display the formula fully. So here we are having dou u by dou x and dou u by dou y, dou v by dou x and dou v by dou y. So when we are differentiating both f1 and f2, okay, here with respect to x and v, so what is u? U is differentiated with respect to x and u is differentiated with respect to y. When we are differentiating u, which is a function of both x and y with respect to x, then we get the first variable as x and the next variable as other than u. That is why we are having here the first variable is y, the next variable is other than u, v. So numerator is common, numerator of numerator is common, dou of f1 comma f2, dou of f1 comma f2, and the complete denominator is common for everything. And here for v, we have to change the position, So if I am differentiating v with respect to x means the second variable is x and first variable is other than v, so we are having u. Okay, and here we are having with respect to y, v with respect to y means second variable is y and first variable is other than v, that is u. So why we are writing like this means always in a determinant that u should come first. Okay, u should come first and v should come next. Okay, u should come first and v should, okay, u1 v1 u2 v2. Okay, so like this you have to think. So first of all, in the numerator here, v should come in the second position. See, second position. So we are writing, instead of u we are writing x in the first position. So v will be common, v will be in the second position. So we are writing v, so v should come in the, so while we are writing v with respect to x means that u should come as common, and here we are having x or y, whatever it is. Okay, whatever it is. So there is no restrictions for x and y, there is no restrictions for x and y. So x can be first or x can be second. Okay, x can be second and y can be first or y can be second, but while we are writing u with respect to x, v should come second. While we are writing v with respect to x, u should come first. You have to understand the formula like this. Okay, that is why I am That is why I am mentioning it very slowly and clearly, because a formula is very important. Okay, because without formula it is very tough to solve any problem. Okay. Dear students, I hope you have understood both the formulas. Okay, I think so. I think you have understood both the formula. So now we have to move on to the problem section. Okay, I am showing these two formulas clearly. Okay, so now we have to move on to the problem. Okay, now the problem is, first we have to discuss the problem under the topic Jacobian of implicit functions, and next we are going to find the partial derivatives using Jacobian. First we shall move on to the problem Jacobian of implicit functions. Okay, now here the first problem, there is only one problem on the topic. Okay, so the problem is if f1 equal to u minus x minus y minus z equal to 0, comma f2 equal to uv minus y minus z equal to 0, comma f3 equal to u v w. Okay, we shall write separately u v w minus z. Okay, minus z equal to 0. Then prove that dou of xyz with respect to uvw, dou of x y z with respect to uvw, that is dou of u comma v comma w, dou of u comma v comma w equal to u cube v. Okay, we have u square v, u square. Okay, u square v. So how to prove this? Now we know the formula. We are having the formula dou of u comma v comma w. Okay, u comma v comma w divided by dou of x comma y comma z, x comma y comma z, x comma y comma z equal to, we are having formula. I shall copy the formula from the above side. Okay, so we are having the formula minus 1 cube of minus, we are having the formula minus minus 1 cube of minus 1 cube of minus 1 cube of dou f1 comma f2 comma f3 of xyz xyz divided by dou u comma v comma w. Okay, so this is the formula. Now I am going to introduce a new formula to you, very new formula to you, that is if I am having, I shall copy everything, I shall copy all these things. Okay, I shall copy all these things. Okay, if suppose I am having xyz in the numerator, xyz in the numerator. Okay, x y z. Okay, yes, given the question, this is our formula. If I am having xyz in the numerator and uvw in the denominator what will be our formula? So xyz in the numerator, x y z in the numerator and u v w the denominator, means it is very simple. So we have to change the xyz to uvw, okay, we have to change xyz into uvw. Okay, xyz into uvw and uvw into xyz. Okay, and uvw into xyz. So the formula is very simple. The formula is very simple. Okay, so you have to understand the formula very clearly. If you want, means you can copy the formula. You can copy the formula as a note. Okay, you can copy the formula as a note in the above topic itself. You can copy the formula. Okay, you can copy the formula here also. You can copy the formula here also as a note. You can add formula here also. Okay, yes, a note we can write, because you may need this. Okay, because you may need this formula. Okay, okay, now I have minimized the size of the formula and I have written it here. Okay, okay, so xyz divided by divided by xyz means we are getting xyz in the denominator of numerator and uw in the denominator of denominator. If I am having xyz by uw means uw will be in the denominator of numerator and xyz will be in the denominator of denominator. So this is your note. You have to make use of this note. Okay, you have to make use of this note. Okay, you have to make use of this note. Okay, now according to this formula, according to our new formula, we are going to find these things. We are going to find dou f1 dou f1 f2 f3 divided by uvw, and in the same way we are going to find dou f1 f2 f3 with respect to x y z. Okay, with respect to x y z. So here I am writing the determinant value. Here I am writing a determinant value that is equal to determinant of first will be dou f1 by dou u. So when I differentiate f1 with respect to u, okay, f1 dou f1, see, I am having dou f1 respect to u. So with respect to u means here I will get, if you know means there is no problem, otherwise I have to write the formula here. So dou f1 by dou u, okay, dou u, then dou f, the numerator everything will be common, f1 divided by dou v, okay, then dou f1 divided by dou w, okay, dou w, and in the denominator, sorry, our second row will be, everything will be f2, and in third row everything will be f3, okay, and in third row everything will be f3. Here it is, here everything is f2, okay, f2 and f2, here everything is f3, here it is f3, and here it is also f3. So we are having minus 1 cube of, minus 1 cube is minus, okay, this is equal to minus 1 cube of, minus 1 cube is minus 1 cube of this divided by, okay, divided by I am copying the entire thing, I am copying this entire matrix, entire determinant, and I will paste it here. Okay, now instead of uvw we will have xyz. Instead of uvw we will have xyz, dou f1 by dou x, dou y, and dou z, okay, dou f2 by dou x, and here it is dou y, and here it is dou z, and here dou f3 by dou x, okay, and here it is dou y, and here it is dou z, okay. So this is our formula. So now we have to substitute the value. Now we have to substitute the value. Now we have to substitute the value for these formulas. So we will have minus of. So when I differentiate f1 with respect to u, I will get 1, and if I differentiate, say I shall copy everything from here, then only it will be easy for you to understand. Okay, f1, f2 and f3. Control plus C, and I shall copy everything here. Okay, control plus V. Okay. And then okay, just a minute. F2 and F3. F2 and F3. So for our easy reference, I am copying all these things here. Okay, all these things here. Next is control plus X. Control plus X. Okay, I shall paste it here. I shall paste it here. Okay. Okay, I shall paste here so that we can refer everything easily. Okay. So you are not supposed to consider this along with this. Just for reference only I am taking it here. Okay. So when I differentiate f1 with respect to u, I will get only 1. And if I differentiate f1 with respect to v, I will get 0. And if I differentiate f1 with respect to w, then also I will get 0. And if differentiate f2 with respect to u, I will get v. And if I differentiate f2 with respect to v, I will get u, and other thing with respect to w means it will be 0. And here if I differentiate f3 with respect to uw means I will get vw. Okay. And if I differentiate with respect to v means I will get uw. Okay, uw. And if I differentiate, so first thing is vw. If I differentiate with respect to, it is vw, and here it is uw, and here it is uv divided by this f1 with respect to x, and f1 with respect to x means I will get minus 1. I will get minus 1, and minus 1. So when we are differentiating f1 with respect to x means we are getting minus 1, and f1 with respect to y means we are getting minus 1, and f3 with respect to f1 with respect to z means we are getting minus 1. Okay. Now f2 with respect to x means it is 0, and f2 with respect to y means it is -1 and it is also -1. Now here everything is both with respect to x and with respect to y are 0. With respect to z means we are getting -1. Now we have to find the values. So since these two are triangular matrix, we can easily find a determinant value, that is minus of 1. Only first term is what, this sides. Okay, so 1 into u square v minus 0. So minus u square v minus u square v divided by, here also first term only this sides. Okay, because here also we are having triangular matrix, so that we can take from okay, if possible I shall take everything. Okay, minus 1 of 1 minus 0, then minus 1 of 0 minus 0, and minus 1 of 0 minus 0. So everything will become 0. See here in the denominator we are having minus 1 of 1 minus 0, and then minus of minus will become plus. Okay, since we are taking determinant, plus then we are having this minus 1 of 0 minus 1 of 0 minus 0, 0 minus 0 is 0, so minus 1 of 0 is 0, and minus 1 of 0 minus 0 is 0, so minus 1 of 0 is again 0. So the second and third term will become completely 0, so it is not necessary to write. So since it is 0, I am writing plus, because 0 is not having any sign, so I am writing plus. So it is not necessary to write these terms here. So for triangular matrix it is only enough to consider first element. Okay, so here we are having only -1, here we are having only -1, and we are getting the result as minus, and we are getting result as u square v, hence we have obtained the result. Hence we have obtained our result. What is our result? What we want to prove? We want to prove dou of xyz. Okay, we want to prove dou of xyz divided by dou of u comma v comma w equal to u square v is now proved. Okay, so we have completed a problem on Jacobian of implicit function.